All right, so what we're going to go over today is Unit 2.4, the Multiview Sketches. So if you've had me in CAD, this is going to be a pretty easy assignment for you. If you haven't had me in CAD, then there's going to be a lot of new here. Really, the two main things that we need to get out of these first assignments in IED to get applied to all the other courses I teach is isometric drawings and multi-view sketching. So I will use the term multi-view sketching and orthographic interchangeably. They're both. I prefer orthographic. The curriculum that we're using prefers multi-view. It is what it is. So, up on the board I have the assignment and Schoology pulled up. So we're going to go through the slideshow. In this assignment, you guys are going to have, there's the assignment sheet, which is going to have all the instructions and everything on it. And then there's the answer packet, which is where you're going to actually answer your questions and take pictures and turn it into them. So the first thing we'll do is we'll go through this slideshow. Alright, so basically what you need to imagine when we're thinking of multi-view sketches is we need to be able to convey enough information to somebody else to reproduce the part that we're trying to communicate. So if we look up here, I've got this die. So if we were going to take a snapshot, a picture of one side of this die, what would it look like? What shape would it be? It'd be a square, okay? So also if we were going to have this be our front view right here, can't really see that on the video, but to where it's got the one dot on it, what's the other shape that we would include? A circle, all right? When we look at this, I want you to think of all shapes are going to have a basic 6 sides. So you're going to have front, right side, left side, top, back, and bottom sides that you can do. Rule of thumb is 3 sides. So you're going to, standard is going to be your front, your right, and your top view. But sometimes you need more, sometimes you need less. If we have a part like this one, so we've got this part right here. If we have this be our front view, and then we look at it from the right, is that giving us any different information than the front view did? No, because it's cylindrical. Alright? What about the top view? Top view gives us some information. Okay? Technically with this part, you could just do the front view because the diameters that you're going to get from the top view are going to be the same as the width. But from just that front view, would we be able to tell that it's cylindrical? No, because it's just going to look like boxes. Alright? Raise your hand in here if you've done anything like this before. Have you done orthographic drawings? I know they do it at Twin. But you did it in CAD. And obviously in CAD you have. That's all we've done up until we got on the computer. Okay, so if we've got our front view has a single dot, and then we spin this to the side, that's going to be our right side view, and that's going to have how many circles on it? 4. Okay, so then we come back to our front view, and then we rotate to our top view, and that's going to have 5 on it. Does anybody without looking at it know what the opposite sides of a dice add up to?
7.
Always 7. Yep. So 1 is opposite of 6, 5 is opposite of 2, and 3 is opposite of 4. So it's a little little piece of trivia there for you guys. All right, so here's an example of a multi-view sketch. How do I flip this? It's mirrored on here. It's backwards. Oh well. Nobody's going to read what it says. Okay. So here's an example of a multi-view sketch. So we've got our front view, we've got our right view, top, and left. Do you think if I gave you all the pieces to put this together, say I cut out all the wood, all you got to do is screw it together, would you need the right and the left side? No, they're the same. They're just mirrored. Okay? So really, the right and left side are redundant. So really, we just need top, front, right on this one. Okay? All right, so here's an example of a multi-view drawing. Okay? This is a lot like what you're going to do. In fact, this is one of the parts from your assignment. Okay? There are some mission critical things here. So what do I mean by that? I mean, it is a in cement rule that happens every time. If you don't do it, you won't be successful. So that's what I mean by mission critical. You have to do it. If you don't, it's not going to work. All right? So, Derek, what do we have to do to make sure that the top, when these two views, what do we have to make sure that they are to each other?
Perpendicular to each other?
Lined up perfectly. Yeah. Okay. I didn't ask a very good question.
You
but
got to make sure you
with,
have that imaginary lines.
Okay. Yep. So we have to make sure that everything lines up always. All right, between our views. So that is a rule every time. So if it's something that changes on our front view, we have to indicate that it changes on our top view. Same with our front view and our right side view. We have to communicate and they have to line up. The other thing that is extremely important is that this space and this space are the same. Does not matter what the space is, as long as they are the same. If they're not, things just don't line up. One thing that we can do, and it's actually a slide here in a little bit, but if we were to just go ahead and say like that our view takes up that room right there, and we draw a 45-degree angle off of that, as long as our spacing is identical, this stuff will line up. And I drew a bad 45-degree angle. But all of these things will line up with each other off of that 45-degree angle. So our top and our front view line up, our front view and our right view line up, and our top and our right line up on that 45-degree angle, okay, off that line. So what are the two things that we have to make sure that we do? Our views have to line up, okay? Everything lines up, and our different views have to be equally spaced, okay? So we have, it does not matter what the space is, just that it's equally spaced. The other thing on this, we'll hit on here really quick. So the solid lines, like you guys have been drawing on your isometrics and your perspective drawings, we haven't really talked about what kind of lines they are, but they're object lines. So our big, bold lines. There's this hierarchy of lines, and we're not going to get into it too much, but just know that the object line is king. It goes on top of anything else, all right? The other line that you guys are going to have to draw, you really only have to know two for this, is your object line, which is your solid lines, and then your hidden lines. So if something happens behind this face, we have to indicate it on our drawing. So there's this slot that goes in here. So when we draw this face, we're going to have a dashed line right here. And just remember that we're going to have our front, our right, and our top views off of our isometric. Now, how do you decide which one is going to be your front view?
Whichever one you're looking at, right? You decide.
Well, if we were in CAD, we could spin that isometric model. Anybody know? Okay,
Isn't
so
it when you turn it left, it's always your front view, and then I can't remember.
okay, your front view should be the view that has the longest dimension, the fewest hidden lines, and the most information. So if we go by those three rules of thumb, do you think they picked the right front view for this drawing? Longest dimension, most information, and fewest hidden lines. Maybe. Okay? It's debatable between, in this one, whether that right side view should be your front view, or if the one that they actually chose as the front view should be the front view. You could argue both. Okay? The front view that they chose does have the longest dimension, but it does not have the most information, and it has hidden lines. So maybe you'd want it the other way. But our isometric sitting like that looks nice and neat. If we spun that, it may not look as good. Okay? So those are rules of thumb, which means we kind of follow them most of the time. But there are exceptions. Okay? So let's go on. Alright, so every object that we have is going to have these three dimensions to it, because we're working in 3D space. So we're going to have our width, we're going to have our height, and we're going to have our depth. Alright, so our top view is going to show us our depth and our width, because we're looking at it from the top. So those are the main dimensions we're going to get off of that. Our front view is going to give us our width and our height, and our right side view is going to give us our depth and our height. Alright, so we can see that here. Alright, so like I said, our top view, we've got our width, and we can tell how wide our part is, and we can tell how deep it is. Our front view, we can tell our height and our width. And then our right side view is going to be our height and our depth. Here you can see that 45-degree line, that these things match up. Now, if you look at that, it's actually, this is a bad picture, because this line goes here. This is a bigger space than this. So just know that we have to have equal spacing. It's not my PowerPoint, so. Well, maybe. Okay, so one way that we can think about this, and my video froze. One way that we can think about this is if we had, say, a glass box around a shape. And the way I like to think of it is if we shined a light from the other side, wherever that shadow was, would be what that we could see from that side. Does that make sense? So if we look at this, if we were to shine a light from back here, all of this right here would be dark. Alright? So we could tell that there was a point there, a point there, point there, there. Alright? Now, if we looked at that from the actual being straight on with it, it would look something like that. There's our points. They all line up here. Okay? So you could call that where it's coming off of the projection plane, but I think it's easier just to think of it of if your light source was on this side, wherever that shadow would be the the darkest would be the opposite of where that light was coming from, and that would be the shape that you're going to create. So here's them explaining that same kind of thing. It's that front face, and then all you would do when you draw it is you'd look at it straight on rather than at an angle like the isometric. Okay, so this is a much better example of all the different views because they're equally spaced. So we've got this shape up here, and it's drawn down here. So if we look at it, they've chosen this to be the front face. So we've got the front face is right there. Okay? So we would see these lines. Oh, that was horrible. Those lines. All right? And that is showing all 6 sides that we talked about. We've already talked about this. So when we look at a shape, we want to find longest dimension. We want the most information and the least amount of hidden lines as possible. So looking at that shape, we would have that be our front view. So what would we see for our front view? Let's go ahead and just draw this one really quick. So if we've got this being our front view, what shape are we going to see?
You're going to see 2 rectangles and a triangle.
Okay, so we're going to have 2 rectangles that go together. They kind of look like an L. All right, so that's this right here. And then we're going to see this line come down to make that triangle. So that would be our front view. And really, it's not quite proportional. That's more like it. Okay? If we look, this right here is 1 unit tall going across, and then this part back here is 3 units tall. So the height of this should be 3 times the height of that. In this assignment, most of it, you're going to be able to just make it proportional. So if something is 5 units and then the next part is 10 units, the 5 units should be half as big as the 10 units. It doesn't have to be a specific measurement on the ruler, but they should be proportional. All right? So let's look, what would our right side view look like? Okay, if we looked at this from this side, can you tell there's any triangles?
I didn't mean triangle, I meant rectangle for the last one.
Okay, so if we're looking at it from that side, we're going to have this right here. So we're going to have this shape. So we're going to see that. All right. We're going to see this, and we're going to see this. But are we going to be able to tell that that's angled if we're looking at it straight on? No. So basically, what we're going to have is a shape that looks like that. And then our top view is going to be same thing, only different. But notice, this lines up, this lines up, this lines up, lines up, lines up, lines up, and our spacing is the same. Again, I'm using a variable because I don't know what that distance is, but they're the same. So they're both a distance apart. All right. main things that I'm going to look for when I go to grade this is that your lines are even, okay? And that they're drawn with a ruler. So even though these are the examples that they're giving us, I don't like how this does not look like they're nice, crisp object lines. And these are examples of how you could take the information from another view and put it, in this case, we've got this shape that's cut out, and then there's a note that says it's an 1/8 inch flat stock. So we know that the depth of this part is that 1/8 inch. We don't see it because we're not looking at, to find the depth, we don't have a top or a right view to find that depth, but it's in a note. Okay? This other one over here, and I know it's hard to see, is dimensioned with diameter. So this dimension right here is shown like this. So they've got their end lines. The dimension is coming like this, and it's got 4 inches, but it's got diameter in front of it. So that part on the right hand side would be like the cylinder that we were looking at, the stair step that I put right here. Okay, so they've dimensioned it with just a view that looks like this, but when they've dimensioned the width or the heights there, they've put diameter on all of those so that you can tell that it's not flat, it's actually, all those dimensions are of the diameter, not just of a distance. On this assignment though, for the most part, we are going to be drawing at least 2 views. Most of them, we will draw 3 views. All right? So we've already talked about this. Everything lines up, equal spacing. This is just showing how you could do this with layout lines. So draw all the lines and where they connect lightly, and then come back and go over those lines with object lines so that they stand out. And then the last thing is they added the hidden lines on there. Okay? Just an example. All right, on this one, so here's 4 different shapes. What do those 4 shapes have in common?
Front, right, and top side.
Okay, they all have the same overall dimension. Okay.
Oh, snap. I didn't even see that.
Yep, the top view is all the same on them. Because you can't see angles, arches, this is angled in. You can't see that from the top view. So all of their top views look like that. Even though all those shapes are different. Alright, so here's your actual assignment. This is the assignment sheet, not the answer sheet. But I want to go through a couple of these with you. Alright, so number 1 here. What you're going to do is you're going to look at the letter on the isometric view and find the corresponding face on the orthographic or the multi-view. Alright? So if we look, A's right here on our isometric. So when we look over here for our top view, it's 9. When we look on our front view, it's 3. And when we look at the right side view, it's 21. Alright, so let's go ahead and do B together here. So we've got B, it's right down here. So where is B on our top view?
14.
14. Where is it on our front view?
8.
8. And on our right side view?
18.
18. Alright, so there's that one. You're going to have a few of these to do where you're going to have to identify which view would be the best front view. So, if we were looking at this shape, what would be our best front view?
The blackest one.
The dark area, okay? So it's going to look something like that. All right? Again, there's no dimensions on this, so I want you to make it proportional and use a ruler so it looks nice. Don't just do this and think that I'm going to give you full credit for that part. Each one of these questions is going to be worth 3 points. So you're going to have your sketch, and then what's the minimum number of views that we could draw with this shape and convey height, width, and depth and all the information from the cuts in it.
Front and top.
Okay? You can do front and top or front and right. You really only need 2.
Oh, yeah.
Okay? So it doesn't matter which 2. But we're going to definitely need our front view, and then we can include our top view or our right side view, whichever one. All right? And then the next question is, which view would you include? So on this one, I would count, if you write top, that would be correct. If you write right side, that would be correct. And if you wrote top or right side, I would count that as correct.
Extra credit.
You need extra credit.
Solid.
Okay. So we've got that one. We've got a few others. Same thing. You're going to sketch out what side would be the front view, and then answer the 2 questions about it. Then when we get down to here, you're going to start drawing some multi-view sketches. You must use a ruler. Not so much for the measurement, but for the straight edge. So if you're working on this at home and you don't have a ruler, find something that's got a nice straight edge. Use a textbook. You could use a piece of metal, whatever, as long as it's got a nice straight edge on it. Okay? So I want to do this one together up here so you guys have an example of what I'm looking for. Yes, because you just got done doing a bunch of these for me in another class. So, again, there's no dimensions up here. So what we're going to do is we have to make it proportional. So what I would recommend is we figure out what side we want to be our front side. So I'm guessing we're going to go front side, right side, top. You do not have to write that on yours. I'm just doing it for the example. All right, so what I'm going to do is I'm going to count units here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. So we're going to find a spot to start on here. We want our overall drawing to end up pretty much centered on here. And so I'm going to start about right here, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my baseline. Again, you're going to use a ruler, so it's nice and neat. We're 1, 2, 3, 4, 5, 6, 7 tall. 1, 2, 3, 4, 5, 6, 7 tall. That's a really crappy line. And then we're 2 units tall there. We got a width of 2 units there, so we're going to come over to here, up, and over. Now, we can get almost all the information we need now from this to draw our other views. So I'm going to space this 2 spaces away. I'm going to figure out my depth is 1, 2, 3, 4, 5. So I'm going to come over 2 and I'm going to go 1, 2, 3, 4, 5. Now, after I do that, I don't even have to look at this anymore. I can pull all the information from this other view because I know that that change has to happen here. And I know that the overall height is right there. Because everything has to line up. Gonna go off my 2 here. I know that it's 5 deep. And then I know that everything has to line up. And there's your drawing. Hopefully your lines look a heck of a lot nicer than those. Because those are not very good. All right, so that would be the answer for that one. Come down and look at number 4 really quick together. gonna have an angle on them?
No. Maybe.
No, you won't be able to see the angle. Only the top view is gonna show that triangle. Okay, 5 gets a little more complicated. We're only going to see angles on our top and our right side view. Our front view will not have an angle on it. Then you're going to get to this last part. And this is where you need to make things proportional. So number 7 and number 8 are in inches. You can use a ruler and actually measure those out if you want. I will. What?
What's number 6?
Hold on, I'll tell you. I'm not going to put a ruler on it, but I'm going to make sure that it's proportional. So if we look at it, it says it's an inch 0.75 wide here, and I can't read that depth. And the depth is 0.75. So it definitely should be wider than it is deep. Number 6